So just for those who are absent. All right. So we're going to begin.
Hi, everybody. Hi.
All right. It's not going to be able to pick up your voice.
Yeah, we don't take laugh.
I'll put the applause like this.
Make jokes, okay? And then we'll laugh.
No. It's got to be organic. I can't just make up something. It's got to come out naturally.
Like Obama's milk.
No, I don't know what it is. Okay.
I don't even know. Mr. Smock was talking about it for like 30 minutes.
Okay, good. Okay, we're wasting time, so let's get going here.
Oh, I got it. Is this like our video?
Yeah.
Like a problem or something?
All right. Yeah, they can.
Oh, hi. This is algebra.
For students who are missing today, so I don't have to do it again.
Okay, Bill. Tennis script graphic.
And cut.
Okay. All right, anyway. So section 8.1 is about inverse and joint variation. So we're starting a new chapter today. The formulas you need for both inverse and joint variation are right here. Now these you will have to memorize.
What's joint variation?
I'm going to get there. I haven't explained it yet. Just be patient.
I thought we already knew this.
No, you don't. It's new.
That's why it's the name of the
This video is so interesting. I'm going to watch it for fun.
Okay, I'll email to everyone. You will have to memorize. Okay?
No.
But once you understand...
Let's put music in
No.
Phil. Just subtly. Just subtly.
Phil, you can't talk.
Motivation instrumental. Motivation instrumental.
No.
I've got it.
Yeah, we got some right there. But
tape his mouth.
no, I get in trouble. I probably would. So we'll have to memorize. But if you understand how they work, it should be really easy to remember. Before I talk about what inverse and joint variation are, we should review direct variation. We did cover this last semester, but you may have forgotten. The formula is y equals kx. Here's the reason why it's called direct variation. If you get k by itself, k will equal y over x. And k represents a constant. What does it mean something's constant? Yeah, or basically never changes. So it never changes its value. So it means that regardless of what y and x are, when you divide those two numbers, it's always going to come out the same for direct variation. K has a special name for it. It's called the constant of variation. So what varies is x and y. And what does the word vary mean? Changes, right? So hence the name variable, because they can change different values. X and y can hold so many different values. But k always stays the same. So if you think about for direct variation, because k equals y over x, what do we call y over x? Fraction, other names for it? Ratio. Yeah, there's more than one variable, so it's variables, that's right. A ratio. What was that?
Have you ever been making videos and someone comes in and makes you talk to themselves?
Yeah, sometimes. Yeah. A lot of times in my house, that happens. So, anyway, so it's a constant ratio. All the time. I've lost my mind. All right, so a constant. No, it's just my voice. It's called screencasting. It's recording all the motions I put on the laptop. No, it's recording everything I'm writing. So I'll replay it so you'll see it again if you want. So now here's the reason why it's called direct variation, which actually I'll do it. I will, I know. So for direct variation, because it's in a constant ratio, if you think about it, if x doubles, then y doubles.
Whoa.
And here's... here's the reason why, because what if what if y is 6 and x is 2? If y is 6 and x is 2, now let's say I double x. So now it becomes 4, right? So what happened to y? It would become 12.
Double.
Oh, sorry.
Right, if I had 6 and 2,
12 and 4.
then if I had 4 at the bottom, y has to be 12. So that's why it's called direct, because they go in the same direction.
Oh, but inverse is like 6 and 2 and there's 3 and 4.
Yes, exactly, you got it. So for inverse variation now, I'll do it over here. Yes, he's actually a pretty smart kid. xy equals k. Yeah, they will.
He's going to be a superstar after this.
Adam Markart, and I think someone else is absent today.
Who?
Adam Markart? Yeah, I know. So
I
xy.
All
Alright. Okay, Phil, enough. Phil, you can't talk. We said this. This is a rule. Alright. So xy equals k. Because if I get x by itself, that's what we get. Now in this case, x times y, what do we call that? When you multiply two things, what's the result called? Product, good. So it means that for inverse variation, you're always going to have a constant product, because again, k is a constant. So in this case, when x goes up, y has to go down. But they go up and down proportionally. So what that means is that for inverse, no, oops, I can't spell, here we go, inverse. So for inverse, if x doubles, then what will happen to y? So y will be halved. So for example, if I had like, as Phil said, if I had 6 and 2, now if I make y double, so now y becomes 4, then x will get halved. Or the other way around. If I had 6 and 2, if I double x, which becomes 12, then y would become 1. So they go in opposite direction. That's why. And also think about it. Doubling is like multiplying by 2. What's the inverse of multiplication? Division. So now you see y gets its name. So that's why you don't really have to memorize so much. Just understand the way it works, and you'll have this down. Yes, vice versa. So let's look at some real-life examples of false relationships, and then we'll do some actual math problems. Like real-life examples are more like word problems. For the classwork you'll do. Yeah, we could. So we'll talk about shadow. Your actual shadow. All right. Let's say if a 30-foot tree has a 60-foot long shadow. Then a 6, like Fabian, are you 6 feet? Yeah, Fabian. I know. We get it, Phil. 6 foot tall person. We'll say 6 feet. Okay, we'll say 2 years ago.
No, you can call me 6 feet. Yeah. Just throw your question.
All right.
Yeah, right. Like 5 feet.
5 feet.
All right. So if we just think about it. Now, of course, we'll assume there's at the same time of day, same angle. So you're staying right next to the tree, so the angle which the sun hits you is the same. So if we keep everything else the same, how long will the shadow be? 12. Actually, be direct. Because think about it. If you're the tree is 30 feet tall, right? And the shadow is 6 feet long. It's a 2-to-1 ratio. So you'd expect, or whatever, 1 to 2. If you're talking about height to length, sure, 1 to 2. then we expect the same thing for the person. So this would be a direct relationship.
How would you measure the length of the shadow?
You have someone help you measure it.
Make a ruler.
Go ahead. Mackenzie, you had a question?
Yeah. So this is a direct.
Yeah.
Constant ratio.
How would it be? I guess never mind. I was just gonna ask how. Would it be?
We'll see. We'll see. Now, how about the next one? If you're driving. Now, first of all, we're driving the same speed. So that's not a variable. That's a constant. You guys might remember this. Dirt. Distance equals rate times time.
Dirt.
Mm-hmm. Distance equals rate times time. So let's say you travel 100 miles in 2 hours. So if you travel 100 miles,
50 miles an hour.
which would be 50 miles an hour. So if now if you travel 200 miles, how many hours have you traveled?
R, is that?
That's like your speed.
4.
4 hours.
What's the R? Is that?
Your rate.
So that last question was there constant.
In this case, the constant would just be the ratio between the height and the shadow. That's it. But in this case, your constant is your speed.
Wait, but is it? Does it make 50 miles?
What was that?
Sorry. Does it have 50 miles per hour?
Well, yeah, exactly. That's your constant.
So R equals 50.
Yes, it does. But what we want to do is we just want to just understand, is this a direct or inverse relationship between distance and time? Distance and time are directly related.
Oh, the
That's all I'm asking you. How are they related? Exactly. Now, the next one, let's say you're working on a project. Try to be a little more realistic. Let's say you're doing some remodeling in your house. You're remodeling the kitchen or bathroom. Let's say it takes 2 people. It will be inverse. Because here's the thing. If it takes 2 people takes 12 days to complete a project. Now, let's say it's not good enough. You want to get the job done more quickly. So you figure, okay, let's double the workforce. Then it takes 6 days. That's just kind of just using common sense, right? You anticipate if you double the workforce, assume that each worker works at the same rate. So it's assumptions you have to make.
Yeah, but if there's like cement involved, is that is not going to dry any
I know we're just trying to let's not present any conundrums or perplexing situations or anything like that. So yeah, Lauren,
What if,
Cameron, I'm trying to hear Lauren. Thank you.
if they made it like a bigger project and then it became 24 days, or would it make it a direct relation?
Well, then if you added more things, you're assuming that the amount of work that has to be done stays fixed.
Okay, so that would be a problem.
Exactly, because in this case, when it takes 2 people 12 days, that's like 24 people days or whatever, or something like that. Or sometimes in construction they call it man hours, like just how many hours it takes to complete a job. So that kind of stays fixed. But if you have more people, then of course the total time it takes to complete would be reduced. Go ahead.
What would you do if we double,
Then, yeah, exactly. So if you only have one person working, it would take 24 days. Yeah. Mhm.
How do you know this relationship is though?
You have to make that assumption.
You have to assume that it will have a level.
Yeah,
Not know this
well, no, what you have to do... No, I just assume double. Let's...
can do whatever. So
Okay, if you want to triple the number of people, you want to triple the number of people, it takes 4 days.
if you add another person that makes
Right? What was that?
you look at the relationship between 2 and 4, and since that's,
Well, actually, 2 and 12. You look at it between 2 and 12.
that's 1 to 2.
No, 2 times 12 is 24.
Are you going to re-record this?
No. So, anyway. So that's an inverse relationship. What was that?
Would always multiply through
What do you mean? What was that?
Yeah, it would.
Multiply 12 and
Or 2 and 12 and 4 and 6.
Yeah. The two variables always multiply 24. Now for chemistry. Apparently, you guys haven't learned this yet.
I have.
Gas laws.
I learned that last year.
Yeah, so I'm going to skip this example. So, but gas laws also use direct and inverse relationship. You'll learn about that when you get to that point.
We watched a video about how cement has to dry properly.
Good.
And that's why
What was that?
because Lily told
Oh, you know that. Are you an AP Chem? Oh, so you do know that. Okay. Well, that follows the same thing. Because P and V would be inverse related, but P is directly related to R and T. Actually, no, to N and T. R is a constant. Okay. Let's do some examples now. Decide whether each equation represents direct variation, inverse variation, or neither. So what do you guys think about part A? The inverse. Very good. And the reason why is because you have a constant product. Because x times y equals 7. So what would V be? Neither.
Why neither?
Great question. Here's the reason why.
This is the plus.
That is definitely a very big reason. But to prove it,
You don't get the number by itself.
nor does a constant ratio. Exactly. See, if I plug in 0 for x, what would y equal? And 1, and 2. So let me ask you this. If I look at each pair of x, y values, do they always multiply to the same number? Nope, so it can't be inverse. Do they always divide to the same number? So it can't be direct, so it's neither. If you divide y and x, the first pair is undefined, 3 divided by 0. How about the second pair? That would be 4. How about the third pair would be? Yeah, so that wouldn't work. So it always has to be in either constant ratio or constant product to be one or the other. The other reason why, too, because the formula is this for direct variation. It's k times x, not k plus x. So as Phil was saying, because you have plus, that's the reason why, too. How about C?
Correct.
Good.
Because you multiply or you divide by y, and then it's 4 equals x over y.
Yeah, so y equals 4x, which is just like this, or if you continue moving things around, you get a constant ratio. Or another way of thinking about it, it's like 1/4 times y equals x. It's a constant times y. Okay. Example 2. So you're told that these two vary inversely, so it means we need this. Well, direct is if it's a constant ratio, inverse constant product. That's all. So if x and y vary inversely, so that's the form we're going to use y equals k over x, because again, you want x to be in the bottom, so if x gets larger, y will get smaller, and vice versa. And also told that y equals 7, x equals 4, so we can solve for k. No, it won't. 7 times 4. You know, you could do x equals k over y. It won't matter. So you could do it either way. So my equation will just be this. Y equals 28 divided by x. You could write it that way too. I don't care. Sure. Yeah. It's not y as a function of x. Yes, it's not right. Yeah, it's not writing y as a function of x, basically. But it is. It is, but it's just not. But you know, it's fine. You still have the right answer. Then this part. When x equals -2, what was that? Okay. So what did y equal here? Which makes sense because we notice how x got halved, so y had to be doubled. And of course, because x got negative, y also got negative. Because we halved x. X was originally 4, now it's 2. Well, actually, it's -2. So now y got doubled. But of course, we had to change the sign. That's inverse. No, because they're going opposite direction. If you're multiplying, then you're dividing. They're going opposite directions. Direct is if you're doing the same thing, multiplying both by the same thing, or dividing both by the same thing.
But, isn't it, product? Oh, wait, that is it.
Okay.
Got it.
Okay, number 3, varies jointly. So going all the way back up here to the first page, when you have varies jointly, basically it's direct variation with multiple variables. So it's direct variation with multiple variables. So going to this one, we expect z to equal kxy. So using these values, we can solve for k. Let's see. So what will k equal here? Not 3. 5. So we have to write an equation, very simple. Z equals 5xy. Yeah, she gets 60 for this one because z will equal 5 times 2 times 6. Which kind of makes sense because x goes down by a third, y goes up by 20%. So it kind of gets back to the same place, but not really. So. Alright, so that kind of covers all those examples. I'm not going to do these multiple choice problems because I want you guys to at least do some work today. Yeah. Okay, so